There we go. Wonderful. Well, thank you so much for joining us here today, Ahmed. And huge congratulations on your first place prize in the competition. And we're very excited to hear more about your approaches today. We would maybe start with a round of introductions. We've got lots of folks on the call, just so you know who you're here with today, and then we'll hand it over for the presentation and then have some space for questions. But I can hop in first. I'm Jamie. I'm one of the co-founders and the executive director at Learning Equality. And you may have seen me pop up in the forums because I was very closely involved with the competition itself and very excited about this problem space and been working around this problem for a few years now. So my background is in cognitive science and then got into education technology, and that's how got into this work. But I have from the cognitive science, I started dabbling in some of the machine learning pieces, and I've been very excited to follow the progress that everyone's made in the competition. Wonderful. Sophia's here too. Hi, Sophia. Glad you could make it. We're just starting our round of introductions. So yeah, I'll pass it first to Blaine, and we can popcorn from there.
Thanks, Jamie. My name is Blaine. I'm a full stack software engineer at Learning Equality. I work on Calibri Studio, which is our content curation platform, which is very applicable to the work that was done in the Kaggle. So I'm very excited to hear what you guys have done.
Awesome. And I'll pass to Liana from there.
Hi, my name is Liana. I am a junior full stack engineer for Learning Equality, and I also work on Calibri Studio with the product engineering team. And I'm very excited to see the presentation today.
And Radina?
Hi, hello, my name is Radina. I am accessibility and QA lead at Learning Equality. And same, very interested to hear in first person live all the progress you've been doing with this, and congrats on winning the Kaggle. Thank you.
And Richard.
Hi, I'm Richard. I'm the product lead, one of the co-founders of Learning Equality. Jamie and I were in the same PhD program, so have some shared background there in terms of exposure to machine learning, but I wasn't as involved with the Kaggle competition, so excited to see some of the results.
And Jose?
Hi, I'm Jose. I'm a full stack engineer at Learning Equality and also a teacher, and I've been wanting to jump onto the machine learning stuff for a long time, so hoping that this will push me to do it.
Great. And Alan?
Yeah, hi, my name is Alan, and I'm a junior Python engineer at Learning Equality. I'm excited to learn more about this and looking forward to that.
Great, thank you. And Lauren?
Hi, I lead partnerships at Learning Equality. Really lovely to meet you. And part of my role is to support our relationship with UNHCR, and we have some of our colleagues from UNHCR on the call today as well.
So yeah, maybe we can pass to Sophia if you're there. Want to introduce yourself next?
Great. Hi, Sophia here, based in Copenhagen. I work for UNHCR Innovation Surveys, and we're supporting the education project, so closely related to all of the activities from Learning Equality. Looking forward also to the other team results. Thank you for hosting.
Thanks. And Alexis is on the move, and you maybe met him earlier, but if you're there at an easy spot, Alexis, could you introduce yourself?
Hi, so I'm Alexis. I'm actually based out of Paris, and I work closely with a connected education team on the Pro-Future partnership, which is a...
Oh, sorry, it was cutting. Go ahead.
Oh, no, it's just, it's an offline learning solution that is used in refugee hosting setting.
Great. And we also have our colleague Nestori on the call, if you're able to introduce yourself.
Hi, my name is Nestori Kabagabe. I live in Germany, and I'm a former Colibri expert and a former refugee teacher, and also Colibri consultant. So I'm so excited to be here. Looking forward. Yeah.
Fantastic. Well, yeah, thanks everyone for joining. And Ahmed, do you want to screen share for your slides to kick things off? And you can introduce yourself as part of that. I think you have a slide on that. And
Yeah,
then,
yeah, exactly.
Jump in from there.
Let me share my screen.
Perfect.
Do you see my slides?
Yes, perfect.
Yeah. Let me shrink this. Okay. Yeah. So as you know, today I will be talking about the first place solution on both main track and the efficiency track. And I will also introduce myself, but it is in the coming slides. So 1 second. Yeah. So today's agenda is like, first I will talk about my background, then I will summarize the pipeline, and as in every competition, validation scheme is the most important thing, I think. Therefore, I will first talk about the validation scheme, then how I represent topics and contents, candidate selection, feature engineering, modeling, post-processing, some interesting findings that I noticed during the competition, and also the efficiency track solution. So this is the outline. So my background is computer engineering. After my bachelor's, I did a master's in artificial intelligence. I am on Kaggle maybe for 6 years or maybe 7 years, but I have been a grandmaster since 2019. I have around 7 years of work experience, including SAP, ING Bank, and NVIDIA. And currently, I am working on my own app. And this is also the reason why I was very interested in this competition, because the competition is for a good cause, and it is about semantic similarity, matching text. And my application is also about matching text. So it is about matching people with similar stories. Like, for example, someone can write a story like, I have migrated to France. I am looking for a job here, but struggling. Therefore, I need to learn some French, etc. And the app can match other users with similar stories so that they can support each other. So with the similarity on what I am currently working on, and with the cause of the competition, I decided to join this competition. So summary, like in short, it is about candidate selection, feature engineering, light GBM model, post-processing. So the metric was F2 score. Therefore, recall was more important than precision. So a good candidate selection was very important. And then, of course, after we have some good recall, then we need good precision. This is where modeling comes. And after that, we have to decide the final predictions. And this is done with post-processing. Validation scheme. So in a Kaggle competition, the most important thing is to set validation scheme correct. Because once you set it correct, then you can do as many experiments you want. And for example, in this competition, I believe mine was mostly correct. Therefore, all my submission scores were correlated with my local scores. I have two-stage model, one for candidate selection, and after I do classification. So in the first stage, I use one-fold validation. In the data description, it was told that source topics were not included in the test set, so they are on the train set. Therefore, I also kept them in my training set. And when it comes to other topics, aligned and supplemental, I got random 67% of them for the training set, and the rest is for my validation set. And for contents, if they don't have any match in the training set topics, then I put them on the validation set. I didn't include them in the training set. By doing this, I think I mimicked how Kaggle or the organizers, you prepare the train test split for the actual competition leaderboard. And for stage 2, my model is much faster for stage 2. Therefore, I could do k-fold cross-validation, and I grouped the folds in terms of topics. The main challenge is also how to represent these topics and contents, so that, because we need to understand how similar they are. And there was some tree structures in topics. So topics had parent topics, and parents also have parents. Like it was like a tree structure, and I found it useful to include up to 3 level up parents. I concatenated their titles with @ symbol, and then at the end I also added the actual topics description. And when it comes to contents, I use contents title, contents kind, if it is exercise or video or something, and then contents description. For candidate selection, I use a variety of methods. Some of them are like very tabular methods. I noticed that there are titles with the same, there are topics with the same title in the data set, and it is possible that in test set you have new topics but with the same title. Therefore, I retrieved all the contents from the same title topics, and I also did the same with title and description instead of just title. And I also retrieved all the contents from the same parent. Let's say if A is in the training set, B is in the test set, but B and A have the same parent, then I use A's contents as candidates for B also. And the other thing, when it becomes more semantic, I use TF-IDF, sparse vector representations. Character foregrounds work the best for me. And for this, for matching this, I use an open source package, which I co-authored actually, because it was memory efficient and fast, and it also helped me to speed up for the efficiency track. And lastly, but maybe the most important retrieval method is transformer models. I fine-tuned transformer models on this data set, and after that I use again top 20 cosine similarity contents. For the sequence length, since we tokenize the text, we have to decide how many tokens we will feed into the model. I found 64 to be optimal, but I only use first 32 tokens output and mean pulled this output. And last 32 is only providing context for the first 32. This worked the best for me, maybe mainly because usually first 32 is about the title and the last 32 is giving information, probably because it is mostly description. I am not really sure, but this is my guess. But this worked the best for me. And I trained an arc-face model. I tried using topics as classes and contents as classes, but contents as classes work the best. So for each content, there is a vector the model is trying to match. And for the topics, there are several contents. So the model tried to match them at the same time. And in arc-face models, you define a margin. to separate classes from each other. If the margin is small, then the problem becomes easier. Margin is large. When margin is large, then the problem gets more difficult. So I increase the margin linearly from the first epoch to the last epoch, from 0.1 to 0.5. I also trained my models for 22 epochs, and first and last 2 epochs have the low learning rate. And also I use a much lower learning rate for my backbone compared to my vector representation learning rate, because I didn't want to diverge much from the pre-trained models, because these backbones are trained on huge data. And if, like, in order to avoid overfitting, it is better to stay close to these weights. And when it comes to submission, I retrain with the full data before making my submission instead of one-fold. And since I have these vectors, I could also calculate the similarity of contents to the train set topics, not only test set topics, but I also calculated similarity to the train set topics. Then I got the most similar train set topic, and I got its matches, its contents as second degree candidates. So this is another way to bring more candidates before classification. And for backbones, I have 4 backbones here. I use only one for the efficiency track, this mini LM1. It is small, therefore it is faster. But for the main track, I use 3 backbones. I tried to use as diverse tokenization as possible because BERT uncase has different tokenization compared to other 2, and XLM Roberta Large is my largest model, therefore it also performs the best, but together as an ensemble, they perform better. Then after I have my candidates, I do some feature engineering. Some of the features are already calculated, like vector cosine distance or TF-IDF match score. I also created aggregation features using them. For each topic ID, was the best TF-IDF match, was the worst among, like in this case, like 20th, because I get top 20. And I also create length features for each text field we have. Other features are same title match count, same representation text match count, or same parent match count. These are calculated from the methods that I mentioned previously. And categorical features, topic language, topic category, topic level, content kind, they were part of the raw data. We could directly use them. And I created one feature called same chapter because I noticed that some contents have text like 14.2 and some topics have text like chapter 14. I extracted them and I check if they match. So it's a binary feature. And another binary feature is if they start with the same word or not. Another binary feature is content, if content belongs to the train set or not. Not means actually it's a new content, and contents max similarity score with the train set topics, topics max similarity score with the train set topics, and if the content is a second degree match or not. So it is like a lot of features, but I guess it is like traditional in a Kaggle competition. And after I have my features and candidate selection, it becomes a classification problem. Basically, if it is a hit or miss, and hits are minority class. Therefore, I overweight them. And I use some little tricks because one feature was very dominant. Vector cosine distance from transformer models, ensemble of transformers. It is very dominant, like by itself, it could also score really good. Therefore, I gave 2 times feature contribution on this, and I also added monotonic constraint because logically it should be monotonic. Like if distance is smaller, match should be better. And the last trick, I tried to use 2 diverse light GBM models. I noticed some of my features may have different distribution for the test set, like aggregation features, vector cosine distance, minimum vector cosine distance by topic ID, for example, because there is a different number of contents in the test set compared to my validation set, and maybe it may be that my validation set is not 100% mimicking it. So it was possible that such features have different distribution. So in one of the models, I excluded such features. I also tried to use slightly different parameters and different seed to diversify these 2 models. Post-processing. So after I have the matching probability for each topic and content pairs, the last part is to decide which are included. So the metric was F2 score. Predicting no content at all was always harmful. So we should always predict at least 1 content for given topic for this metric. So always the best match is always included. And among the train set contents, if they have above 5% matching probability, and if they have less than 25% gap with the highest matching content for the same topic, they are included. So this relative probability is very important in this competition because you include 1 content, let's say it is 90%, it has 90% matching probability, but the next one is 50%, then it is better if you don't include it for the metric. But if the first one was 60%, then the second one with 50% is better to add it. So it is about the metric. And I did something different for the test set contents. If they have less than 5% gap, they are included. And if their total gap is less than 55%, they are also included. So total gap is actually the gap between so contents gap with the best content for that topic and plus content's best maximum similarity score. So I compare with the best matching one, and I compare within the topic and I compare within the content, then I get the total gap. I know this sounds very confusing, but maybe with code you can understand it better. Yeah. So when it comes to findings, one thing I noticed in the data, there were near duplicate topics in the data. So topics with the same title, and when I look at them, obviously they also have same contents or similar contents. So this may favor a bit overfitting models. If you consider using such a model in production, I think train test split could be done better in terms of maybe split by topic tree, or if we try to put duplicates in the same fold, then it can be better for a production case. Also, what I notice, models don't only learn semantic similarity, but also they learn graph structure. Because if I only use pre-trained models, which has some semantic similarity, it performs poorly compared to my trained models. And the gap hints me that models also learn the graph structure, not only semantic similarity. And the last part is, as in most Kaggle competitions, post-processing was very important. In this competition, I think when I read also other solutions, one key difference is I approach train set contents like a classification problem, and the test set contents like an assignment problem. So I try to find a match for each test set content, but when it comes to train set contents, it's like a match or not a classification problem. So this is actually, this is like explanation of my post-processing technique. And for efficiency model, as I explained before, instead of ensemble of 3 large models, I use one small model. It took 20 minutes on CPU, and it performs around 0.74, which could get a gold medal actually in this competition. So yeah, one could use this model if time is the consideration. Yeah, maybe I explained things fast, so if you have questions, I'm happy to answer.
This is fantastic. I've got lots of questions. I also know I might get into the weeds quickly, get very detailed quickly. So I wanted first, for a lot of folks on the call, they weren't as close to the problem or the data and maybe have less experience also with some of the machine learning concepts. So I just want to leave a chance for us to walk through any kind of the high level questions or concepts that people want us to dig in on a bit before we go into some of the details. Are there there's a lot of terminology and a lot of detail here. So if there's anybody that wants to kind of dig in a bit on any piece of that, feel free to raise that. I think I'll just kick things off, but then anybody just interrupt at any point with their questions. The last piece that you're talking about there with the post-processing, I think is very clever. And like you said, is one of the things that probably pushed you above the edge there. I was curious if anybody would kind of settle on that strategy, because it's, so just to clarify for others, we have a subset of the data that's withheld for the test data set. There's a specific set of topics that have never been seen that we're making predictions for. With the content, some of the predictions might be for content that was already in the training data set because it's shared content from the library. Some content is only exists in the testing data set and wasn't in the training data set. And so what Ahmed realized is essentially there's more nuance to this, but there's a higher probability of that content being recommended in certain contexts because it has to go somewhere. Whereas some of the other content might not get used in the testing data set, but the stuff that's only in the testing data set that wasn't in training, we know has to be recommended to some topic at least. We could have put extra confusers or extra distractors in there, but we didn't. So that was a really clever insight to figure out that, yeah, you use different thresholds basically, and you approach it as it has to go somewhere assignment type problem rather than just a classification of does it go here or not.
Yeah, that's one reason. The other reason also, the train set contents are seen by the model. So since model could see them, model could also represent them better. Mm-hmm. So knowing them, this flag, model could distinguish, know how to behave for 2 of them.
That makes sense. Yeah, they're less. It might perform worse with them because they're unseen. So you need to change the thresholds because of that. Yeah. Leave another gap.
And I could mimic them locally with my validation set, so I didn't tune anything on. I didn't have to tune anything on the leaderboards. I just did everything locally, and it worked the same on the leaderboard.
Yeah. You emulated that, like you're saying, in your validation set. So I'm just getting a sense of folks' familiarity. It might be useful even just explaining what the purpose of multifold validation is. in something like this, just for folks who haven't worked with?
Let me go back to my validation. So first of all, as I mentioned, I have a two-stage model. Let's forget about the second stage, maybe. Let's first talk about the first stage. In that case, I'm training these retriever models, basically transformer models, actually. And I used only one fold validation, which is one split. I split the data to train and validation. And my main objective is to make it as similar as possible to how the competition host or Kaggle split the data. And in that case, I use all the information I have on the description page to mimic this. One is source topics are not in the test set, right? Since I know them, I kept all of them in the train set. And then the rest, the supplements and align, I just randomly picked 67%, and the rest is for the test set. And for the contents, if they only match with the validation set topics, then they are also excluded from train set. So my model doesn't see them. My model only does evaluation on them. So this was the split.
Okay. Opening for others' questions. Feel free to just ask basic clarification questions or things that you were curious about in terms of the approach, and then I'll jump in with some of my other questions after. Everybody's pondering. If you're, oh, go ahead, Sophia. Yeah.
Yeah. So because you said what I found really interesting, and thank you for the presentation, it was really clear. You said that you're doing matching of stories, let's say, and this one had a different structure in terms of even how the words are connected or anything. Did you notice, were there things that were not applicable to the other type of classification that you do to this one, or something that you had to fine tune, like to adjust, given that this is the format of the text for this training set?
So one very important thing for this text specific is the tree structure. So I had to add the parent information from the parent categories, like compare. If I understand your question correct, what is the difference with other traditional semantic similarity tasks, right? So in that one, the main difference to me was this tree structure, how I represent the topic. But once you represent topic and content, this is another difference actually. Like these are two different types of text. One is topic, the other is content. But once you have the representations, it is actually very similar to any other text matching problem.
Well, while we're on this slide, one of the things I was curious about is the choice of putting the title of the topic itself at the beginning and then going up the breadcrumbs as you go further out into the string. Did you try that in different orders? Like, I think probably just because it's the way we see it on a website. I think when I was trying this sort of thing previously, I was doing kind of the grandparent or the top level, the root topic at the left, and then going out to the right. Is there a bias in some of the backbone models to have the richest semantic content at the beginning of the sequence, or did you try different structures?
Main consideration is that I had limit of tokens, right? So only 64 tokens, or actually the first 32 is more important than the last 32. So if I didn't have and I believe topic title is the most important, for example, here. If I had it at the end, maybe for some examples, model couldn't see the topic title. So I actually sorted them according to the importance that I noticed in the data.
Yeah, that makes a lot of sense. Yeah. And I've seen it from some of the generative models as well, like the text to image models, that it seems to pay more attention to the early tokens in the sequence as well. So you're probably benefiting from that as well. So that's really good to learn.
So this is an example of those 64 tokens. So you took the first most important and then the last ones, as you said, like the last 32.
So I don't really have the actual example, but it tokenizes, for example, in this case, these triangles, maybe it is like maybe 4 tokens, like try and less or something like 3 tokens. And if I count 64, maybe it will end up around somewhere in the middle. Let's say calculate the interior part. Maybe it is the interior is maybe the 64th token. So because the tokens are not words, but like 2-3 letter things, and then it will focus on the first 32. So the first half, in that case, probably the title and the parent titles, and it will use the description as additional context.
And that, I guess, also answers one of my other questions, which is why you don't also include for the content any of the text content from the content. It's just probably because you're not going to use much of it anyway because of the truncation in your models.
Yeah, for content, actually, when there is no description, I forgot to mention this. I use text if there is no description.
Okay.
And for the TF-IDF part, I had also TF-IDF model, right? TF-IDF could look at the whole data. Like it doesn't have to truncate. For TF-IDF, one trick I did, I duplicated the title to give more importance to title, but it looked at the whole data, whole text, let's say. So it is one difference between TF-IDF and transformers. And difference is always good in machine learning. It gives you diverse candidates.
Yeah. Folks may remember, I think I mentioned TF-IDF at the presentation a couple of weeks ago as a way to go beyond just bag of words. So you're looking at, in this case, it's, I guess, a 4-gram, that's sequences of 4 characters. And I'm looking at kind of the distribution of probabilities across all the text, and then which ones are overrepresented in a particular piece of text. And that's kind of the signal that you use to indicate. So
if something is very common, then it gets less weight because matching this is just easy. But if something is unique, then it gets more weight.
And I think it sounds like it's also part of what made this such a fast solution. So like yours, I think was I don't know if I've seen the scores of how much time each one took, but I think you also won the efficiency prize, and that 20-minute time is very impressive, because one of the things for us as an organization is we work offline a lot, and this model will most, like the initial use case is online in our curation tools to recommend to somebody organizing the curriculum. But using a similar model offline on like a Raspberry Pi or a low power device to be able to make recommendations or match search results and things in a low power offline device is also a very powerful use case for us. And so your performance in the efficiency track inspired us that maybe there is potential for loading this just for pure CPU, low power device type inference. So it's really exciting.
Especially TF-IDF, like since it is sparse matrix multiplication, it is fast, and I use an open source library here that I co-authored, and it makes it also memory efficient. And I could use also 4 cores. Kaggle provided 4 cores for the inference, so you can parallelize the matching. So yeah, in general, then it is much faster compared to transformers vector generation.
The feature engineering you did was also very impressive. You had a huge set of features there, so it'd be interesting to hear a little bit. So just clarifying for folks, so these features are essentially in the second stage model, so this re-ranking type model, the one that's making the decision about which ones to include. These are basically the inputs to that, so that some of these come from the first stage, some of them are computed separately, and then you're throwing all of those in, and then it's learning which of those have signal and which of those tell you about whether it's a good match or not. But yeah, I'd be curious to hear a bit about your process for like how you built out the set of features from the initial ones, and then how you decided to add certain things, and if there were features that you tried and made it worse, or that didn't add anything that you rejected, or if some of these are, you mentioned, I think the vector cosine from the transformer models as being one of the best signals, I think, but yeah, curious if you, yeah, what some of the other strongest ones were.
Yeah, vector cosine distance is the most important feature here. Like by itself, it could be very competitive in this competition if I didn't have a second stage model. And the others, they each contribute a little, and in Kaggle you need these little contributions. And one thing I wanted to have, I didn't want to spend a lot of time in feature engineering, not only my time, but also computer's time. Like I didn't want to have any complex feature. Most of the features here, they come for free. Like once you have TF-IDF canvas, you also have their TF-IDF score. And some of the features are just from raw data, language, level, kind. And length features are very easy to calculate, or the same title, same representation text, same parent match count. These are already calculated in order to do the retrieval. And maybe the most complex feature could be same chapter or not. And this is just looking for with some, I could use some regular expression, but I did something simpler. And with some assumptions, I extract a chapter, and which is not always 100% correct, but it is correct most of the time. So it gives some signal to model, and it is up to model to decide when to use it. This same chapter is, the, let's say, most different feature among them. The rest is usually product of candidate selection pipeline.
Anybody have questions about the features or these pieces, or other questions? Just leaving space.
It would be good, I think, to say like a feature importance, kind of like ranking, but the vector cosine distance makes sense. It represents the text. Any other ones that were coming up as most important?
Let me see, maybe I can find it on my, sorry, this.
I guess it's harder to say than in a pure regression type model, because you don't just have the single coefficients that shows how much they're weighted in, because there's interrelatedness in a decision tree of like, this one becomes more important when the other one is there, or when the other one is certain value.
Yeah, exactly. When they are correlated, they look like they are not important, but actually together they are important. Like, but again, this is just gain importance. This is not 100% correct, but vector distance is the most important, as you can see. And the topic channel was also improving by my model. I used it as a category, so it seems for some channels, matching behavior is different. So model can extract some signal from channel. And the third feature looks like second degree, if the match is second degree or not. And the fourth one is if the content is from the train set contents, or if it is a new content. Yeah, but the main thing is vector distance.
Is gain importance, is that where you remove it and then see how it
no, actually this is directly from the model. Like when model used it, how much, so model optimize an objective, right? So it how much it optimized using this feature is the gain importance here. So normally for feature importance, I use LOFO, leave one feature out. So I retrain the model by removing one feature out. But in this case, I started competition with very basic feature set, and I only edit features if they improved my model. So each of them contributes, some little, some large, but I didn't really log each of them's contribution. I didn't log the sequential process that I did in my experiments. but at the end, I ended up with this feature set.
Okay, great. I'm curious. So one of the challenges in this competition was it's only positive examples. There's no explicit negative samples, true negatives. Curious if that impacted the way that you approached the problem, and how you think, once we are able to collect some true negative examples, how that would influence the approach that you would take, or where you might incorporate that into the pipeline.
Yeah, for second stage, I created my own negative examples, right? Since I have candidates and some of them are real match, some of them are false positives. So then I created some my own negative examples for the second stage. But for first stage, it was more challenging. But with ArcFace model, you actually, all of the vectors, all of the other vectors are your negative sample with the ArcFace model. Some people in this competition, they didn't use ArcFace, they use other types of training, and they had to generate negative examples. But when you use ArcFace, you don't need to generate negative examples because all other vectors are just your negative examples.
Including even the other positives, I guess, for that, but they just balance each other out, or?
So I made contents as classes. So for each content, all the other contents are negative examples. And for the topics, I used, they could match multiple contents, right? So it was like not hard classification, but let's say soft classification. If it matches to two contents, then it is like 0.5, 0.5 for these topics, for these contents. And then therefore model tried to, let's say we have one topic and it matches to content A and content B. Model tries to separate content A and content B, but model also sees that this topic is similar to content A and content B. Therefore, it tries to make this topic, content A and content B, similar to each other. Because I provide this information for the topic. And therefore, it tries to make them similar, but the rest of the contents, they becomes further and further apart from these two.
Okay, fantastic. Yeah, I think one of the other kind of insights that you found in there was also doing that topic to topic comparison in your second stage to find additional candidates that that met like a similar topic, because that's something that in our use case could be quite strong as well, because often people are curating for similar curricula, and so finding that topic that has already been that matches it closely, that's already been curated elsewhere, and then choosing that content directly rather than just relying on content similarity to each other or to the topics was a really powerful approach.
So normally, let's say if the data was totally about semantic similarity, maybe this was like a redundant. This could be redundant because once you represent your vectors well, then they are similar at the end. You don't need to retrieve the second degree. But if you imagine that some topic matches to some content, but they don't look semantically similar, but they are a match for some reason, and then with this method, you can retrieve them with the second degree. So that was the advantage of this method, because I believe in the data, not all the matches are semantically similar. There were some outliers.
Yeah, that makes sense. So you're able to capture both of those dimensions.
Yeah.
It's kind of like you said, the graph structure also.
Yeah, exactly.
Other questions from folks? Anyone on the team curious about part of the solution? One thing I was just going to spotlight, so we have your video in there. You mentioned it a little bit earlier about the app you're working on and how that related to your motivation around the problem space, but also curious if there's other motivations around the impact of this competition, or the use case and the way that the way that this is going to be used that was part of your motivation, or if you have any thoughts about or feelings around the impact of the work that you did in the competition.
Yeah, previously I think I also joined another competition organized by you, so I had also enjoyed that one. If I'm not mistaken, I think it was from you, because you guys had several competitions on Kaggle before, and it was always fun. And this one was very similar to what I am currently working on, as I explained before. And it is not and I feel like it could be really useful. I mean, maybe the model just out of box may have some things to fix, like I mentioned, the duplicate problems, but after it becomes like ready for production, then I think it can be really used for the good of students.
Fantastic. Yeah, curious about the role that your own education, and you've been in industry for a while now, but the value that you saw from your own education in supporting what you then chose to do in your career, and kind of your beliefs around the value of education and the importance of education. If you have anything to share there.
I'm not sure if I understand the question correctly.
It was a bit vague. Yeah, basically just understanding your the value that you see in education, either in terms of the value that it provided to yourself or to the world or to the communities and the countries. Just your own kind of belief in the value of education, or not, but curious on your take.
Yeah, so I am located in Istanbul, Turkey. So the education is our main problem. Like since it is recorded, maybe I don't go very political about it, but the education is the main thing, I think, for the society. Like if education is in bad shape, then it affects the generations after generations, and it is really difficult to fix. And it is what is happening to Turkey, for example. Education gets worse and worse, and then we have more issues coming. So I personally can suffer from the bad designs in the education, and therefore I am able to notice that it is the main thing for the society.
Thank you so much. Yeah, no, thank you for sharing, because it's always valuable for us to hear, that piece of, and for you to understand also that you're going to have a huge impact through these solutions that you created for learners around the world, and to help improve and make content easier to find and easier to use for teachers and for students. So yeah, we're super excited about the contributions that you made.
Thank you.
And I think we do have some content in Turkish. I'm not sure, but hopefully we can help to support education in Turkey as well.
Yeah, I noticed like some of them were labeled as Turkish, but some of them had titles in French. Like it, I guess it happens with any data. There's always some noise.
Yeah.
But I noticed some, and because I could understand only two languages here, English and Turkish, and when I develop models, I always try to debug models myself. Like, why model made a mistake here? Like, this is how I iterate. I train my model, I do my pipeline. At the end, I check the mistakes model does. And if it was only Italian, French data set, I wouldn't be able to do this. And English, maybe I see English mistakes, but maybe it is only for English. Maybe it is not common in the data. So it was an advantage for me that dataset also had Turkish, so that I could investigate models' mistakes more.
Fantastic. We have just a couple of minutes left, but want to open up for others. Doesn't need to be deep technical questions, but if you have any other questions for Ahmet before we close out.
I just want to say thank you for this presentation and your work. This is pretty cool, and a lot of it went over my head, but I'm really looking forward to learning more about it and everything. So this was great.
Thank you.
Hi. Personally, I don't have a question, but I just have a little bit of your perspective in your tech experience from what you had described before. How interesting? What did you find interesting dealing in the education materials vis-a-vis your previous tech experience? So what did you think? What do you think was a little bit interesting in the education materials in trying to go through them?
So I think maybe similar to my previous answer, like how to represent the education material is the main challenge here, I think. Like because once you have good representation of the education materials, the rest is actually similar to other text matching problems. So how to use description, text, and how to extract the information. I also tried other methods that didn't work, so I didn't include them in the presentations, but I was able to extract, for example, authors from the text, and this kind of information I could extract, and this was very domain specific, and at the end they didn't really help, but I could experiment with such features. Yeah, so I think the representation part was very unique for this data set.
Thank you.
Before we close out, curious if you have any kind of top recommendations for us as we take the model and work to build towards production. You mentioned, some cleanup and things like, things that might be artifacts of the specific way we structured the competition data, but in terms of types of data we might want to collect to help with further training, or other ways we would carry it forward. Curious if there's any.
Yeah, to me, the main thing before production, I think, to separate these near duplicates in different folds, so that otherwise the performance may be overestimated. And once the folds are well separated, then I think it will be a solid model for production.
Fantastic, thank you. Great, well, really appreciate your time today, and thank you everybody for joining, and congratulations once again on your dual win. And we're very excited to bring this into production and experiment with more data, and hope we can stay in touch and maybe find ways to collaborate in the future.
Yeah, thank you very much, and thanks for organizing such a competition. It was really fun, and it was really well organized, and you were always helpful also in the discussions. So it is really good to see organizers take care of the competition for Kagglers especially. So it was really nice. And if you have any question about my solution later, you can always reach out to me.
Fantastic, appreciate it. Yeah, I'm going to spend time digging in on the code soon. Great, thank you so much. All right, well, thanks everyone, and have a good evening, Ahmed, and we'll hope to talk again.
Thank you. Bye.
Thank
you.
Take care.